The topic that we'll be covering today is a post machine. Post machine sits at the same level at which a Turing machine sits, or a two stack or n stack PDA sits, which means that it is capable of solving the same category of problems that are solved by the other two machines. सो जो पैराडाइम है वो हम सेम में हम जा रहे हैं जो भी हमारा इस वक्त जिस हम पैराडाइम में है एंड पोस्ट मशीन इज another way of solving the problems that could have been solved by Turing machine or two stack or n stack PDA. So what I will do is in the first I will start with introducing a post machine which design is very simple, and then we'll solve the same problems that we solved using Turing machines and two-stack PDA. So you can have an understanding how the same problem can be solved by different types of machines. So post machine is based on the queue, while PDAs are based on stacks. Turing machine is based on random access memory. Post machine is based on a queue. We have studied queue in our previous courses, we have studied stacks in our previous courses, and we've also studied arrays या जो random access memory है हमारे पास in our courses. But I'm not really sure if we have realized that an array, random access memory में अगर उसको analogy दूं, वो a queue, they have the same power, while stack does not have the same power. However, if I increase the number of stack to 2, then I can get the same problem solved by any of the three structures, right? And also, of course, logic base mein aa jati hai. So let's begin without further discussion. Let's have a look at how post machine looks like. So this is how a post machine looks like. So somehow I felt that whenever we talk about machines, something complicated or technically challenging, or visually, hard to digest comes into our minds. But actually, our machines are very simple. On paper, it is just the logic that we are embedding into these machines that are going to help us solve our problems. Every machine solves a separate problem. Like every program that we write solves a different problem. Every algorithm is specific to a different problem. Similarly, every machine that we make over here is a concept that is there to solve a particular problem. So, आपके सामने we have again the reading जो हमारा जहाँ से हम read करते हैं अपने string को, that is still a tape. That tape is the same read only once traversable tape that we have always been doing. So our tape has always been, input tape has always been the same, except for the case when we have been looking at the Turing machine, where we could just move left or right, or we could also overwrite on it. So I'm talking about a simple input tape. Now the structure where I can store my intermediary or output, whatever, is a queue. So you can imagine that you have a queue, and queue basically has two operations. You can read something from the queue, which is from the tail, and you can add something onto the queue, which is on the head. We also use the terminology NQ and DQ. You are free to use any terminology. However, in this course, I will be using the conventions of read when I am doing DQ from the queue, and I will be using add when I'll be enqueuing onto the queue. However, if you use a different terminology, that is definitely not going to be affecting your any sort of grade or any marks. So here you can see there's a specific start state. There's a specific accept state, and then you have some reads, and then you have some adds, and that is it. So read means you are reading from the tape. Sorry, read means sorry, the tape doesn't exist over here. I apologize for for not guiding you properly. It just slipped my mind. Post machine actually works on only on queue. It does not have any tape, right? So you read whatever you do, like you read or you NQ or you DQ, happens on the same queue. Okay. So you have a read where you're reading from the queue, and you have add where you're adding to the queue. So whatever processing you are doing, that is happening at the queue. So over here, if you assume that your input tape, right? So मैं assume करती हूँ कि मेरी input, let's say this is my queue and this is my input, right? So if this is my queue, I add my hash to it. So आपको पता है, you can always add to the end of the or to the tail of the queue. So I add a hash. Then I come to read one. Giving this number read one does not mean that read has some specific meaning. It's just that if I want to refer to a particular read, then I know this is the read I'm talking about. Okay. So read one says that if you've read an A, you do nothing, right? You go to read number two. So you read from the head. So when you read from the head, you do nothing. आप बस इसको just read and then like just read it off and don't add, right? So it just simply means that you discard it, right? Okay, it doesn't exist on the tape anymore, a queue anymore. And then any from read number two, you can see any further A that you read, you have to read and you have to add them to the back of the tape of the queue. So these two A's are read while this A has been added at the end of the queue. Then the moment you start reading your B, the first B you should read and you should not do anything, and you should simply just let it go. Any further B's that you encounter, you should be adding them to B. Now anybody can guess, and you keep on doing it until you read a hash. Anybody can guess what language is this machine trying to solve? It's a very simple language that we've seen many times. Anybody can guess what the language is? A and B. Yes, excellent. So, so let's now that you've gotten the hang of the basic working of and design of this machine, let's go to build a little more complicated machines. Let me plug in from my tab so that I can start solving them and designing the machines. I hope I hope everybody can see the shared screen. Right? Okay, so let's begin. So you have seen very simple example of A and Bn, right? So maybe if you come to think about it, there could not be a simpler way of solving this problem, right? So you're reading and you're discarding. मतलब जैसे होती है कि stream में से A's और B's आते जा रहे हैं. You are discarding the first occurrence of A, the first occurrence of B, and then you copying the rest at the back side. So I think this is one of the easiest platforms that A and B and could get so that they could be solved. I am sure that PDA is also easy. However, it has not been that easy when it came to solving on the Turing machine. अच्छा मैं थोड़ा सा मैंने आपको इंट्रोडक्शन दिया था, मैं इसको मशीन को दोबारा से बनाती हूँ. तो व्हाट यू डू इज यू हैव अ स्टार्ट. ठीक है. assumption ये है कि मेरे पास दिस इज माय क्यू, राइट, एंड ये मेरा टेप हेड है. सॉरी सॉरी मेरे मुंह से टेप पता नहीं क्यों निकल रहा है बार बार. So this part is my head, right? जहाँ से मैं DQ करती हूँ, और this part is my tail, जहाँ से मैं NQ करती हूँ, right? आप इसको different terminology के साथ भी कह सकते हैं, front back भी कह रहे होते हैं लोग. So you come to a start. The first thing that you need to do is that you need to um, add a hash. ठीक है? हैश हम ऐड क्यों करते हैं? हैश हम इसलिए ऐड करते हैं कि हम सेपरेट कर सकें from our string from the of the previous iteration with the string of the next iteration. ठीक है? अगर हम ये नहीं करेंगे तो we will not know when to stop. We'll just keep on doing it. In very few problems, this is just not required. But in most of the problems, a separator is required जो कि आपकी string को from one iteration to the other separate कर सके. So you put a hash, then what you do is you read, right? So read means we dequeue from our. So जब हमने read किया तो हमारा आ गया A. आपने कहा okay, if it's the first A, let it be. उसके बाद हम क्या करेंगे? फिर दोबारा read करेंगे. अब रीड करने में if I get more A's, right? So what I will do is I will save them. So whenever you will add an A, you read an A, that A is going to be added to the tail of the queue, right? At the end of the queue. So आप देख सकते हैं कि ये जो end वाली चीज है, जब आगे वाली चीजें हटेंगी, तो end वाली चीज automatically front पर आ जाएगी, right? So this will be the beginning of the string of the new iteration. So as long as you have A's, ठीक है, add करके दोबारा, and as long as you have multiple A's, you keep on reading them until you hit a B, right? The first B should be balanced with this A. So you let it be and you'll go to another read. So you'll give it another, so any excessive B's that you have, you will read and you will add extra B's that you get, you will add them. The adding means you will be adding it to the tail. Right? And when you get a hash, so ultimately जब आप करेंगे उसके बाद you will end up getting a hash. Hash means your first iteration is over and now is the time that you begin your iteration. ठीक है? So हम लोगों को, आपको पता है concept है iteration का, redoing the things. So this iteration is complete. अब जो A भी रह गया है, इसको दोबारा से वो ऐसे go through करेगा जैसे कि it's a new fresh start. So again you will add a hash, right? You will read. Color change कर लेती हूँ. So you will read. You'll read an A. This is the one जो कि आप corresponding जिसका B ढूंढ रहे हैं. So you'll read again. No extra A's that need to be stored. You get a B. So you read a B and then you go to another read and you encounter a hash. जैसे ही hash आया तो आपने क्या किया? hash को add किया और आ गए अब read पे. अब आपको पता है जब कुछ नहीं होता तो हमारे पास null होता है. So you find a null, right? अगर hash के फौरन बाद you find a null, it means there's nothing on the queue, right? So this is the time that you should accept. इसके अलावा if there's an imbalance in the number of A's and B's, your machine will crash at one point or the other, right? वो आप इसको trace करके कर भी सकते हैं. अगर if it's not clear तो मैं इसको दोबारा बता देती हूँ या हम एक और example कर लेते हैं इसकी, जैसे आप लोग कहते हैं. जी, असल में मसला ये है कि रीड करने से पहले आपको हैश ऐड करना ही पड़ेगा. अगर आप नहीं करेंगे तो फिर जो रीड किया होगा वो फिर या तो रीड के बाद आपको डालना पड़ेगा हैश. कोई इसकी कुछ समझ नहीं आता. सो आप करके भी देखिएगा. सो putting a hash in the beginning is a preferred way, right? जी हैश हमें रीड करना ही पड़ा है. मे बी इसका डिफरेंट भी कर सकते हो, बट दैट्स मे बी अ क्लीनर वे ऑफ डूइंग इट. अच्छा, मैं इसकी ना आपको एक और एग्जांपल हम लोग कर लेते हैं ताकि चीज आपकी क्लियर हो जाए, राइट? अच्छा, इसको आप आराम से स्केल कर सकते हैं, आप आराम से इस प्रॉब्लम को स्केल कर सकते हैं ऑन टू ए एन बी एन, ठीक है, सी एन डी एन ई एन, आप जी तक आराम से स्केल कर सकते हैं। सो एक बार रीड करते जाएं, सबको कैंसिल करते जाएं। सो मुझे क्यू वाला काम तो आसान लगता है फॉर दिस प्रॉब्लम, बट आई विल नॉट से इट इज ईजी फॉर ऑल द प्रॉब्लम्स, लेकिन फॉर दिस पर्टिकुलर प्रॉब्लम क्यू मुझे लगता है शायद सबसे ही आसान है। सो लेट्स से मेरे पास इनपुट है, लेट्स से मेरे पास इनपुट कुछ भी नहीं है, ठीक है, मैं नल ले लेती हूँ, ठीक है, लेट्स से दिस एवरीथिंग जस्ट कंटेन्स नल, ठीक है। सो मैंने किया स्टार्ट, ठीक है, मैंने किया हैश ऐड, मैंने किया हैश को ऐड किया, राइट, और उसके बाद मैंने किया रीड। सो व्हाट आई रीड इज अ, सॉरी आप क्या कहते, व्हाट आई रीड इज अ, नहीं आप मुझे हाल से आप सही बात कर रहे थे हारून, हम जब करेंगे मैं शायद क्वेश्चन ही आपका, सो व्हाट यू विल रीड, अगर आपको हैश आएगा तो आप एक्सेप्ट करेंगे, यू राइट, यू हैव टू रीड अ हैश, मैं शायद समझ नहीं सकी आपकी, सो आपको इसमें हैश करना पड़ेगा एंड देन यू विल एक्सेप्ट, राइट। सो आई थिंक जिस तरह से मैंने सॉल्व किया है, वन थिंग ये कि वी नीड टू बी लिटिल मोर कंफर्टेबल विद मेकिंग मिस्टेक्स, ठीक है। Secondly, we need to be clear that by doing different, running our machine on different types of strings, it is possible for us to identify any problem that we have with our machine, right? So whenever you make a machine in your exams, what you should do is you should, whenever you've made it, try running onto two different types of strings, like giving it an empty string, like I just did. This highlights and helps you fix anything that might have gone wrong. Okay. Okay, let's look at another. आप लोग इसको A N B N C N पे कर लेंगे, or should I be making it for you? Okay, so let me move on to another problem. आपको पता है जब हमने प्रॉब्लम की थी इक्वल इक्वल with with a single stack, equal equal is solvable by a single stack. Single stack से इतना आसान नहीं था, two stack से बहुत easy हो गया था, and when we were doing it using a Turing machine, so it was not that easy, right? However, if you try to do it using a cube, the logic is still simple. So equal equal is a language where you have equal number of A's and equal number of B's. Okay, so let's say you have, right? So let's say this is your, first of all, let's work on building the logic, right? So what I will do is, I will, there are many ways of doing it, right? So my one iteration, I can do two passes for my, for every iteration. In first pass, I cancel an A because we don't know, we might be getting B in the beginning. And the second pass, I can be getting a B. Another little complicated logic would be that you start off with whatever A or B, then you branch out, and then you look for the other corresponding pair, right? And by in the meanwhile, you keep on copying uh, the rest of the letters, right? So for the convenience of the class, I will be going with a simpler method, which is the first method that I have discussed, in which I will do two passes, right? Maybe it's a little longer, but it's simpler to understand. However, I would recommend that you, after the class is over, you should go with the other one too. Okay? So what I will do is, so I start, right? And I, sorry, the first thing I need to do is, you should not forget it. जब भी Q हो, तो you always begin with starting a hash. Hash is there to separate your string of the previous iteration with the string with the new iteration or the other pass. So you read. So what I'm doing is, I am looking for As long as I read an A, I am okay with it, right? क्योंकि मुझे A से start करना है. Otherwise, अगर मैं B read कर रही हूँ, ठीक है, तो इसका मतलब है कि मेरी logic ऐसी है कि I have to look for the first A and then in the second pass I'm going to look for the B. So I keep on adding B's until um, until I until I find the first A. So जैसे मुझे first A मिल गया, what I will do is I will just not do anything with it because that is the one that had to be cancelled. I will go again and I will read, right? And I will read as long as I have more A's. Yeah, I've cancelled the first A. As long as I have more A's, I will keep on adding A's, okay, until I hit the first B, right? उसके बाद मैं क्या करूंगी? Now that I've cancelled my A with the B, which means equal हो गया है, one A has been uh, balanced by a B. अच्छा, मैंने वो दूसरी वाली बना दी आप लोगों के सामने. आई थिंक ये नहीं करते. ये करते हैं कि A जब आपने रीड कर लिया, राइट, उसके बाद आप क्या करेंगे? आप सारा कुछ कॉपी कर लें, ठीक है. A रीड कर रहे हैं तो आप A ऐड करते जाएं, ठीक है. और अगर आप B रीड कर रहे हैं तो आप B ऐड करते जाएं, ठीक है. उसके बाद आप रीड करें जैसे ही हैश, तो इसका मतलब है दैट योर फर्स्ट पास इज ओवर, मींस यू हैव एक्चुअली कैंसल्ड वन ए. अब आप क्या करें? यहां से दोबारा स्टार्ट करें, ठीक है. यू स्टार्ट, आप क्या करें कि आप यहां से अब दोबारा से ये वाला पार्ट जो है ये स्टार्ट करें, बट दिस टाइम नाउ यू कैंसलिंग अ बी, राइट. और बाकी सबको आप सेव करते हैं और ये प्रोसेस आप करते जाएं. इतना करें कि जब आप पहला रीड करें, आपको पता है यहाँ से हमारा एग्जिट होना चाहिए, सो यहाँ पे हमारा आए एक्सेप्ट, right? So this is how your issue of or problem of equal can be solved. Okay, मैं अगले प्रॉब्लम पे चलूंगी, जो कि एक और प्रॉब्लम को हाईलाइट करता है. दो अ वेरी सिंपल प्रॉब्लम, ठीक है, वेरी सिंपल प्रॉब्लम विच इज एक्चुअली अ CFL, ठीक है. अच्छा, no matter how simple this problem seems, because we recall the grammar was very easy to make, it is a problem that is solvable by a single stack. I don't, we can, it is also very simply solvable by using a Turing machine. However, the same post machine which was helping us solve A and B and C and D and E and F and problem like equal in a very simple way gives us hard time when it comes to solving a simple problem like palindrome. It is because of the design, right? I will tell you the reason. Right? अब मसला ये है कि the issue with dealing a palindrome is that this is your NQ and this is your DQ. The issue with using a palindrome is that this middle point is not known. That is the reason. When we were using PDAs, we were using the non-deterministic PDAs that will figure the middle part out for themselves, right? और ट्यूरिंग मशीन्स भी हमने लेफ्ट और राइट घूम घूम के हम लोगों ने की थी, इफ यू रिकॉल, राइट. सो पोस्ट मशीन में जो होता है, पोस्ट मशीन में मैं हाईलाइट करती हूँ कि व्हाट इज द इशू, कि आप किस तरह से इट्स अ प्रॉब्लम कि आप पोस्ट मशीन से जिस तरह से हमने इसको पढ़ा है इसको सॉल्व करना किस तरह से मुश्किल है. अच्छा, अब देखें, व्हाट वी हैव टू डू इज, आई एम जस्ट ट्राइंग टू बिल्ड द लॉजिक. नाउ आई एम नॉट गोइंग टू मेक द मशीन. What I will do is I will read an A and I will not store it, but I will remember by the flow of the whole diagram that I had previously read an A. Right now, what I need to do is I need to read, and um, if I'm reading these three, I need to read and I need to save them on the onto my queue. And for this particular A, I need to cancel it, which means I do not need to store it. अब मसला ये है कि when we are looking at this A and this A, right? We don't know um, whether this has to be stored or this has to be cancelled with this A, right? मैं आपको रन करके बताती हूँ. हम रन करके देखते हैं, राइट? सो मैंने सबसे पहले हैश डाला, ए रीड किया, मैंने कहा ओके वी आर लुकिंग फॉर द करस्पॉन्डिंग ए एट द एंड. अच्छा, ये ए रीड किया. अब मुझे बाय लुकिंग एट दिस ए, देखिए कॉन्टेक्स्ट हमें नजर आ रहा है कि इस ए के इस साइड पे बी है, इस साइड पे ए है, बट द मशीन इज जस्ट सीइंग अ स्ट्रीम of where A is at the top, and it's very hard for it to decide what is depending upon uh, uh, by just looking at A to decide what's going to be coming next to A. So यहाँ पे वो अगर डिसाइड कर भी ले कि ओके मैं इसको यहाँ पे ऐड कर देता हूँ, राइट? बी आ जाए वो कि ओके मैं इसको यहाँ पे बी को ऐड कर देता हूँ, फिर एक ए आ जाए वो कि अच्छा मैं इसको ऐड कर देता हूँ. अब दिस ए इज नॉट नो डिफरेंट फ्रॉम एनी ऑफ द प्रीवियस एज दैट इट हैज सीन. सो वो क्या करेगा, वो इस ए को भी ऐड कर देगा. अब जब हैश रीड करेगा तो उसको ख्याल आएगा, ओह द लास्ट ए दैट आई एडेड was the one that had to be removed. We have to find a way to be able to read the last letter, right? Or the second last letter अगर हम इसको भी count करें तो. So we need to have a way of doing it. क्योंकि अगर मैं इसमें भी लास्ट लेटर का देखूंगी तो आई विल नॉट नो कि कब मेरे पास हैश को रीड के बगैर आई विल नॉट बी एबल टू टेल दैट दिस इज माय लास्ट लेटर, राइट? आर यू ऑल गेटिंग व्हाट आई एम सेइंग?
Yes, ma'am.
Okay, so let's come up with the algorithm कि हम इसको solve कैसे करेंगे. First I will tell you the complete solution, and then we will make a sub program that will be used like we had done insert and delete. We'll also make sub programs that will be helping us solve them. So what I will do is, अब आप mind में रखिएगा आपने करना क्या है. What you need to do is that, let's say I have a very simple problem, ABA. What I need to do is that I don't need to read just one. I actually need to read two elements, right? Two letters, and then decide what has to be done in the with my first letter that I had read. And then what has to be done with this B is not determined by just reading this B, but determined by the next letter that it is in. Okay, it's just like we look at the context of the letter, or we look at the next letter that is coming, and then we decide the fate of this letter, whether this has to be added or it is the one that has to be cancelled, right? So what I will do is, I'm going to take the same example, right? So what I will do is start with a hash, okay? हमारा एक de facto सा बन जाएगा हमारा. So I will begin with an A, okay? And I don't know whether this is the letter I should be saving or I should be comparing. So what I will do is, this has to be of course cancelled. This B, I do not add. I do two reads simultaneously. And once I find that this is not hash, what I do is I add this B, right? And then when I read this hash, having read this A previously, I decide that this is the A which is the last letter, and I need to balance it with this A, right? I will take another example, little longer example. So let's say so the first thing that I do is I put a hash. The first letter that I read is an A, and I'm looking for the corresponding A that comes at the end. So I look at this B. I don't do anything to this B. I read another B, and then I decide on this occurrence of this B, I find out that this B is actually not my last B. So it's good I add it at the end. Then about the fate of this B, I go to the other read this B, and decide the fate of this B, that this has to be added. And when I read this A, I decide the fate of this B, this needs to be added. This A, on reading hash, I decide this is the one that had to be cancelled. So for the A that I started out with, I am going to be cancelling it with this A, and I am done, right? So my first iteration is done, and I can continue it with this iteration. Is everybody okay? Can I go on to designing the machine? We are in a way reading from the outside towards the center. No, actually, we are doing two reads. We are actually reading these two, then I'm reading these two, then these two. But we don't like actually read it again and again, but we just, it's like, it's just like looking ahead before deciding about your current position. No, the problem will not come. So we have like A, B, and A. No, the problem will not come. So अगर मैं इसको देखूं continued हो, for example, ये मेरी so hash हो, I will start with an A, this A, and decide about this A after I read a B. So I put an A. Decide about B after I read this B. So I have a B. Decide this B after I read this B. Decide this A after I read this B. Decide this A after I read this, right? And then इसका मैं जब इस पर decide करूंगी तो hash आ जाएगा. So I will know this is the one that has to be cancelled, right? So I will start fresh. इसको मैं A triple B A, right? So I will have I go down to A, sorry, A triple B A बन जाएगी, right? Triple A. So I will begin with a hash A, right? Yes, yes. The every iteration removes the first letter and remove the last letter. If I were to sum up this problem, the problem is that palindrome requires that you balance the first letter with the last letter. Discard them. Then your second letter becomes your first letter, and your second last letter becomes your last letter. So at every iteration, you are balancing your first with your last one. The trouble with Q is that you can just read from the front, you cannot read from the back, right? So you either you write a utility that we will be writing how to read from the back. Otherwise, you will just be able to read from the front or the tape and be able to add to the tail, right? So let me just come up with this logic. Logic बना देते हैं हम इसकी. So what I need to do is I need to start. ठीक है. अब आप देखेंगे कि पहला लेटर अगर A होगा तो you will go differently. पहला लेटर B होगा तो you will go differently, right? So what you will do is अगर A है तो the other letter that you're looking for is an A, and the B है तो the last letter that you're looking for is a B, right? So आप क्या करेंगे? आपको करना पड़ेगा सबसे पहले you will do the add, right? तो मैं मिस ही हो गया कि ऐड किया हमने हैश, राइट? उसके बाद मैंने किया रीड, ठीक है? रीड किया है ए तो कुछ और करूंगी और रीड किया है बी तो कुछ और करूंगी. सो आई विल जस्ट बी राइटिंग वन पार्ट. अगर ए रीड करेंगे तो फिर हम क्या करेंगे? उसके बाद हमें एक और रीड करना पड़ेगा, राइट? सो दैट दिस इज द ए दैट हैज टू बी डिस्कार्डेड एनीवेज. ये हमारा स्टार्ट वाला है. सो आई विल बिगिन. स्टार्ट किया, लेट्स से रीड मैं यहाँ पे ए भी कर सकती हूँ या मैं यहाँ पे बी भी कर सकती हूँ. ये ऐसा ही है कि अगर मेरे पास ये लॉजिक हो, राइट? सो ये तो मैंने यहाँ पे डिस्कार्ड कर दिया. उसके बाद जो ये वाला ए आया है उसको मुझे सोचना है कि मुझे इसको कहाँ पे रखना है. सो मैं इनको नंबर भी दे देती हूँ, रीड नंबर 1, रीड नंबर 2. सो जब मैं इस ए को रीड करूंगी, सो व्हाट आई विल डू इज आई विल नॉट डू एनीथिंग, राइट? आई विल डू अनदर रीड. मुझे एक और रीड करना पड़ेगा. यहाँ पे भी मुझे एक और रीड करना पड़ेगा, right? Read 2, read 3 and read 4, right? So no matter what I do, आई हैव रेड दिस ए बिफोर, अब मुझे एक और रीड करना पड़ेगा, यानी कि एक ए रीड करने के बाद मुझे ये रीड करना पड़ेगा और उसमें से मुझे ए भी मिल सकता है, मुझे रीड करके मुझे बी भी मिल सकता है, राइट? इफ आई रीड एन ए, राइट, इसका मतलब है दिस ए इज डेफिनेटली नॉट द लास्ट लेटर, सो व्हाट आई विल डू इज आई विल ऐड ए, राइट? और अगर बी मिल गया है तो भी मैं क्या करूंगी, आई विल ऐड, आई विल स्टिल ऐड ए, राइट? लेकिन मुझे ये याद रखना है कि मेरा अब ये बी है विच इज इन द एयर एंड दैट हैज नॉट बीन, दैट स्टिल नीड्स टू बी एडेड, राइट? सो इस ए को बाद में क्या करूंगी, आई विल गो बैक, राइट? सो मैं क्या, अगर मैं इसी स्ट्रिंग को चलाऊं, मैंने क्या किया, मैं कलर अगर चेंज करूं तो मैंने सबसे पहले यहाँ पर आई, मैंने रीड किया ए को, फिर मैं यहाँ पर आई, फिर मैंने रीड किया एक ए को, राइट? और फिर मैंने रीड किया तो मेरे पास आ गया बी, राइट? बी जब मैंने रीड किया तो मैंने कहा कि ओके दिस ए इज नॉट द एंड, तो मैंने इस ए को उसके एंड पे ऐड कर दिया, राइट? जैसे कि अभी मैंने किया। अच्छा, फिर मैंने क्या किया है, फिर मैंने क्या किया है कि अब मेरे पास ये दूसरा पार्ट भी बनाना पड़ेगा, राइट? सो अब मेरे पास क्या है, बी है। अब मुझे यहाँ से कहाँ जाना है, ए पे तो मैंने डायरेक्ट कर दिया, राइट? अब बी रीड करके मुझे यहाँ से मुझे यहाँ पे भी बनाना पड़ेगा, विल हैव टू हैव अ रीड, ठीक है, जिसमें मैं ए भी रीड कर सकती हूँ, मैं उसमें बी भी रीड कर सकती हूँ, ठीक है? उसके बाद फिर मुझे रीड करना पड़ेगा, फिर मुझे रीड करना पड़ेगा, राइट? 3 4 रीड नंबर 5 रीड नंबर 6, राइट? अगर ए रीड किया हो या बी कुछ भी रीड किया हो, लेकिन अगर आपने पिछला आप पिछला आप अगर सो अगर आपने पहला ए रीड किया है या आपने फिर बी रीड किया है, राइट? दोनों में से कुछ भी किया होगा तो व्हाट यू विल डू इज यू विल हैव टू डू अनदर रीड, राइट? और फिर आपको क्या करना पड़ेगा, सो अगर आपके पास यहाँ पे ए भी आ सकता है और यहाँ आई एम जस्ट शॉर्ट ऑफ स्पेस, ए आ सकता है और यहाँ पे आपके पास बी भी आ सकता है, तो आप ऐड क्या करेंगे, इसमें ए ऐड करेंगे क्योंकि आप ए इस की फेट डिसाइड करें, राइट? और यहाँ पे आप क्या ऐड करेंगे, आई थिंक ये क्योटिक होता जा रहा है, आई थिंक इट्स अ गुड आइडिया दैट यू नो वी जस्ट डू इट फ्रॉम द, हम उसमें से कर लेते हैं, अपनी स्लाइड में से कर लेते हैं, राइट?
मैम आपका माइक म्यूट है।
ले कब से म्यूट है? मैं तो, अच्छा आप लोगों ने मैसेज भी किया, मैंने शायद गौर नहीं किया। सो मुझे इसको दोबारा से बताना पड़ेगा। ओके, सो हमने क्या है, हम करना चाह रहे हैं कि आई जस्ट वांट टू ऐड टू द, आई वांट टू रीड दिस, राइट? सो मैं इस रीड करना चाह रही हूँ। द ट्रबल इज दैट आई एम जस्ट नॉट एबल टू रीड फ्रॉम द टेल ऑफ द क्यू। आई कैन जस्ट रीड from the head. However, computer science can always find their ways out. So what we will do is we'll find a way out so that we can also read from the back. We can also read from the tail. So my target is to read this A, right? So मैं अब क्या करूँगी? As you can see, the first thing that you do is you put a separator or a marker that separates your first string of the first iteration with the string of the second iteration, right? इसके बाद हम क्या करेंगे कि we can have a read and पहले अगर मैंने A read किया है, ठीक है, तो आप देख सकते हैं कि it's going to read number 2 and read number 3 and read number 4 depending upon what you've read, right? And this is one of the ways of remembering or putting it in memory that you have read an A, right? Because of the flow. So if you're standing on read number 2, you know that you're coming from the part where you have actually read an A. If you're going on read number 3, you know for sure that the previous, but it's a memory that you've put, that you have a B. Read 4 पे आप खड़े हैं तो आपको पता है you've actually read a C, right? So that's one way you can keep a track of your, you can also remember things, right? So A को read करके you come to read number 2. Now you can see no matter what you've read next, whether it's an A or a B or a C. So जो उसका context है, जो next letter है, whether that's an A or B or a C, what you add is you always add an A. This is just to make sure that the A that you had read from read number 1 was actually not the last A, right? आप उसको ज़ाया नहीं करना चाहते हो. So this is now read. उसके बाद आप आए, next what you do is you come to read number, they say you go to read number 2 again. Since it was an A, it referred you back to read number 2, which is the read that remembers that it was your A, right? That was in the A and that has to be added. अब उसके बाद आप देखेंगे तो you have a B, right? So what you will do is no matter you've read a B, but you will be still asked to add an A, right? And this A is going to be removed from here. Now this B says that after you've added the A, you need to refer to read number 3. Read number 3 takes care of the fact that you have an B pending in the air. So depending upon what happens or what occurs after B, you decide to add a B, right? So what you read after reading the B is you read an A. So whether you've read an A or a B or a C, you add a B. However, you are referred to different reads, which will lead to different adds yeah, until you end up getting the last letter. Okay. So this B is referring you to read number 2 because what you read was an A, right? So this A is something which is in the air, some memory, some imaginary place that we are storing it. And then we come to read number 2. What we read next is again an A. So you decide about the fate of the previous A, that was not the last letter. Then you go again, come to read number 2. Now read number 2 pay you read, and if you read a dollar, right, it means that the A that has been read but has not been added was the last A, right? So there can be multiple things that you can do. If you're looking for a palindrome, then maybe you cannot do anything with it and you can start your iteration again. और इन द अदर वेज में ये है कि अगर आपका मतलब अगर आपने किसी प्रोग्राम का पार्ट अगर आपने लिखना है तो यू कैन ऑल्सो डू इसको आप टेलर कर सकते हैं अकॉर्डिंग टू द प्रॉब्लम. But is reading two things at a time and deciding about the fate of the first letter that you have read, is that concept clear? Is that clear or should I be doing another example from it? Okay. So let's look at another. So जो मैंने आपके साथ किया है, it is reading from the back. You can just assume that this is a sub program that you can use. I will be explicitly mentioning you if I allow you to use it in the exam. So depending upon the complexity of the problem, if the problem is complex, we generally allow you to use these sub programs like insert and delete and read from the back. However, if the problem is not too complicated, then we just expect that you do the functioning of these sub programs into the machine itself, right? So एक और इसका है that Q का ये भी है that read you cannot add to the front, right? So this is one algorithm, one concept where you can add things to the front, right? So हमें पता है जब भी हम queue में add करते हैं, what we do is we actually add things to the end. So if this is my queue, anything that I need to add, I will be adding it to the end, right? If I want to add something over here, that will just not be possible. However, we need to write subprogram. It is possible. As computer science people, we know we can do things by the slight manipulation or little bit of building logic. We can actually make them do the things. So let's say मैं अपनी में ना I want to add letter B जैसे यहाँ पे लिखा हुआ है, right? So what I do is first I start with a dollar. Dollar separates my string from the previous iteration with the string that is in the next iteration. Next, I add this B. Now this add B that you first encounter it is adding the letter that you want to add in the front. If you want to add X in the front, right? So you will be replacing X over here. Over here, they've just added the letter B, right? उसके बाद आप क्या करें, वो कह रहे हैं आप जो रीड करते जा रहे हैं आप ऐड करते जाएं. If you read an A, you keep on doing it cyclically. You read an A, you add. You read a B, you add. You read a C, you add. So you read an A. Read means you're reading from the head. A, you add an A. You read an A, you add an A. You read a B, you add a B. Right? जो read करें वो add करें as it is copied. And once you're done with when you read a dollar, it means now you have successfully added your letter in the front, right? So that was tweaking your queue so that you could add things to the start of the queue, right? So this is one subprogram which is add front. There's another subprogram which is read from the back, read from the tail. इसमें एक जो हमने काम किया है वो ये किया है जो मैंने अभी आपको दिखाया था. उसमें ये किया इन्होंने काम कि जब आपको डॉलर मिलता है तो आप क्या करते हैं, उस लेटर को जो कि आपने लास्ट में रीड किया उसको आप फ्रंट पे ऐड कर देते हैं और फिर आप उसको रीड कर लेते हैं. सो दिस इज एक्चुअली कंप्लीट करता है आपके रीड बैक वाले कॉन्सेप्ट को, राइट? Generally, unless it's not mentioned, you cannot use these two utilities, right? ये जब explicitly mentioned हो तो तभी आप इनको use कर सकते हैं. इसमें वो जो सिमुलेटिंग वाला काम है वो आप लोगों ने नहीं करना. यू डोंट रियली नीड टू डू दिस. जो पिछला वाला पार्ट है ना इसमें हाउ टू सिमुलेट पीएम और टीएम, ये वाला काम आप लोगों ने नहीं करना. एंड एग्जांपल है, यू कैन जस्ट गो ओवर देम. ये ट्यूरिंग मशीन है, पोस्ट मशीन है, सॉरी. तो ये आपके बस दो काम आप लोगों ने इसमें करना है. सो यू शुड नो पोस्ट मशीन में, यू शुड नो हाउ टू डिजाइन अ पोस्ट मशीन. You should know how the two subutilities were read back and add to front, how these two work. And I think that's about it that you need to know from post machines. Any questions?